Hello, so in this video we're going to be looking at the product rule. Now we use the product rule when we have two functions of x multiplied together. So if you see, this is a function of x and we're going to multiply it by x plus 3 and x times x plus 6. Now this is what the product rule looks like, this thing up here. So what we've got is, you can see that we've got two things multiplied together. One is called u and the other is called v. The notation can change, but one is called something and the other is called something else. And basically what the product rule says is if you can differentiate by leaving the first term alone, differentiating the second term, leaving the second term alone, differentiating the first term. Okay, so one of them we're always leaving alone and the other one we're differentiating. Okay, so here's an example. We want to differentiate this, y equals 2x times x plus 6. We can choose which is going to be our u and which is going to be our v. It makes some sort of sense to have the first one as u and the second one as v. Then we need to work out the bits we need. So we need the dv by dx and we need the du by dx. Okay, so dv by dx comes from here. Now when we differentiate a constant times x, so this is like 1 times x, you just get the constant, so that will be 1. And when we when we differentiate a constant, we get 0. And if you're not sure of that, please go and visit my video on differentiation. And then when we differentiate u, which u equals 2x, we'll just get the 2 because we got that constant, a number times x. Now we just put it all together by putting it into our product rule. So we put u. So we go back into the question and look at what did we have for u. So u equals 2x. We do 2x. dv by dx is here, put it in, plus v we want next, so here's v up here, times by du by dx. Put that in there. And then hopefully when we expand that and sort it out, we get this answer here. So really it's just sort of substituting, and it's just remembering what the formula is. So I'll say it once more. I remember that you leave one alone, differentiate the other, leave the other alone, differentiate the first one. Okay, so here's a second example. So we do exactly the same. We label one as u and the other as v. We differentiate. We've got dv by dx. So here we've got x squared plus 5. When we differentiate x squared, we multiply by the power. We take 1 from the power. 2 take away 1 will give us 1. And then when we differentiate a constant, we get 0. And then du by dx, when we have a constant times x, when we differentiate it, we just get that constant. So that's where that comes from. And now we put it all in our formula here. So we've got u is 4x, so that comes in here. dv by dx is this 2x, which comes there. Plus v, which is right up here, comes there. And du by dx is this 4 and comes there. And hopefully when you expand and sort that out, you get this answer here. Okay, so a slightly harder example. Now the reason this is harder, because we've got one function of x times another function of x, where this function of x is a function of a function, because we're squaring all of this function of x. Now, hopefully you remember how you do this. You use the chain rule, and if you don't remember the chain rule, please go back and look at one of my videos, my video on the chain rule. And I think what people find hard with this is if you use the notation, we've suddenly got slightly different notation to use. Okay, so let's just work our way through it. Now, just first think about this one. We'll need du by dx, and hopefully everybody now knows that du by dx for this would be 1. So I've just written it down here. And then I'm letting my v equal this one. Oops, there we go. So when we use the chain rule, if you remember, what you do is you label the thing inside the bracket as some sort of letter, and it doesn't matter. We've used U before, but we're going to use P today because I don't want to confuse it with the other U's and V's. So we let P equals x plus 3, and that would mean that if this was P in here, we can say V equals P squared. I think we can differentiate both of those straight off without writing them out, hopefully. So what will the chain rule be? We're looking to find dv by dx. That's what we're aiming for. And what we do is we say, okay, well, it's in terms of p. So we got dv by dp times dp by dx. Now sometimes people get them the wrong way around. So just remember that when you finish this, the dp's and the dp's should cancel, leaving you only the dv by dx. Okay, so if you've got it wrong, what you'll have is you'll have two dp's on the top, and then that won't work. So now we just substitute in. So dv by dx is dv by dp, so that's from this one. So v equals p squared. You'd bring the power down to differentiate, and then you take 1 from the power, so the 2 will become 1. And then differentiating this, we've got 1x, which will just differentiate to 1, and the 3 will differentiate to 0. So that's times 1. So don't forget, at this point you have to go back into your original notation, so you can't leave this p, so you need to add in that x plus 3, so you need to substitute out that p. Okay, so now we've got that, we can just go through all of this, just putting the various parts in. So we've got u is x, and dv by dx is this thing here, plus v, which is x cubed plus 3, and du by dx is 1. And hopefully when you multiply that all out, you'll get this answer here if I haven't made a mistake. Quite possibly I have, but anyway, that's the answer I have here. So the key thing is just to go steady. Just remember what you're doing. So you've got the product rule, but then to differentiate, you had to use the chain rule. Anyway, I hope that's helpful.